So we started looking at Kubernetes there yesterday, and what we were talking about was creating pods. Pods are the kind of lowest or most fundamental resource, as we call them, within Kubernetes. And the way you create a pod resource, just as you create any other type of resource, is through a manifest file, which can be written either in YAML or in JSON. And so we looked at our first manifest file yesterday, and there is one line in it that I overlooked to explain to you. So if I bring up the file again, so the line that I didn't talk about is this line here, and really that's the line that was the source of a lot of the problems that I was having back around week 3 when I started to introduce this topic. Effectively, the function of this service account line is to give the pod permissions to do certain things, and in particular, it gives it permission to pull an image from a remote Docker registry, Docker hub in this case. Now, so essentially, kind of the way you interpret this line is that there is uh, a policy, a security policy that was created by the Walton people that are managing this cluster, this Kubernetes cluster for us. And the name of the policy is this name here. Okay, so you can tell from the name that it's a policy specifically for this module, really, to give the people that are studying this module the necessary permissions, but not too much permissions in order to complete the various tasks that I want to work my way through over the next couple of weeks. Okay, technically it's a service account that has been created with this name, and that service account has a security policy or security context associated with it, and that security context has various permissions assigned to it. That's kind of what's going on there in the background. We won't get an opportunity to look at the security aspects of Kubernetes, unfortunately, but that's just the explanation for this particular line. If you comment out that line and try to run the OC apply command, then you will find that it's unable to complete the creation of the pod. It can create the pod okay. It can give the pod an interface, meaning it can assign an IP address. But then when the pod tries to initiate the pulling of the image, that's where it falls down. So apart from that, then these manifest files all have the same kind of high level structure, which is this structure here. Every manifest has to have an API version field in it. It has to have a kind field in it, kind as in what type of resource does this manifest file create. It has to have a metadata property or field in it. And the probably the most important part of the metadata are the labels that you assign to this particular resource. Annotations are important as well. We'll see one instance of annotations being used, uh, but probably there's only one actual annotation that we will come across. And then the main part, I suppose, is the spec, which is the specification, the kind of detailed configuration, if you like, of the particular resource that the manifest file is trying to create. And so in the case of the pod, uh, this was the detail that we talked about yesterday. So all of that is fine, hopefully. Now, there is one other actual, there's another point as well that I didn't mention to you yesterday. So to log into the cluster, we use the OC login command. Now, um, the cluster API server, if I bring up the slides again, we go back to kind of this diagram. So whenever we use the OC command, which is the CLI that comes with the OpenShift container platform, the OC command is communicating with the API server, and the API server is just like any uh, API server in that it's listening on a port, and the port it's listening on is port 6443, which presumably is a configurable. There's nothing special about port 6443, but that is the port that is being used by the API server of the cluster that we are using. Now, there are restrictions on TCP ports that are open on the college Wi-Fi network, mainly because of the cyber attack that occurred there last year, I guess, wasn't it? So there are only a certain number of TCP ports that are open on the college Wi-Fi network, like port 80, port 443, which is for SSH. Uh, the port that we want to have is not open, even though I've requested it to be open, but it takes quite a while for these requests to go through. So the upshot of all of that is you cannot use the college Wi-Fi network when you're practicing any of the labs or playing with the Kubernetes cluster that we are using. You'll have to use either your own mobile phone hotspotting, or if you're working from home, your own home Wi-Fi if you do have Wi-Fi at home. So that's just a word of warning to you. If you try to log in, it will fail, and it will fail because it cannot access the particular port that you're trying to use. Okay, so let's carry on with our slides. I think this is, yeah, we've covered all of that. Okay, so a pod is the fundamental resource that you can create in a Kubernetes cluster. The next type of resource that we want to look at is what's called a replica set resource. And just like pods, if you want to create one of these replica set resources, then you need to code up a manifest file for it. Now, what these replica sets are is an ability to create multiple copies of a pod. And that's something we would want to do in order to maximize the availability of whatever app is running in our pod. And those replicas tend to be deployed onto different worker nodes also to maximize the availability characteristic or quality of our application. So rather than creating individual pods ourselves and making sure that those pods are assigned to various worker nodes, then instead what we do is we just code up a replica set and let the Kubernetes platform take care of doing the kind of low level heavy lifting, if you like. Okay, so that means how do we write a manifest file for a replica set? Let's go back to VS Code. By the way, the name you give to these files is completely arbitrary. So here I've got a file, and if we take it from the top, the type of resource or the kind of resource that we're creating in this file is a replica set. Now, how do I find the API version what's the API version value, if you like, for replica sets? Well, the way you find that out is by using the OC API resource command. Remember this command, API resource lists all of the different types of resources that are available to us on Kubernetes. Now, rather than generating the entire list, if we do a grep of replica set, then here we go, replica set. RS is the short name for a replica set. Uh, app app slash v1 is the version, the API version, and the kind is, where does it tell us the kind? The kind is kind of way over here, replica set. Yeah. So taking all of that, we can now use that information in our manifest file. So that's why I've set API version to apps slash v1. I've set kind to replica set, capitalized. Metadata, again, metadata, the main properties of metadata are the name you want to give the replica set, which, as I said yesterday to you, is arbitrary. We could put labels as well on a replica set, and I haven't done that here because we don't really need them. And there are also possible annotations that we could include in the metadata, but I don't need them either here. So I'm just using name as the only metadata that I'm setting, if you like. And then we have the spec or the specification of her replica set. Now, the properties of a replica set spec, one of the main ones is this property here, which is really stating how many replicas or how many copies of the pod do you want to have created. And I've just arbitrarily decided I want 2 copies. Uh, the selector part here, so the selector kind of specifies the labels of the pods that you want to have associated with this replica set. And this is reinforcing the point that I made yesterday and earlier on this morning about the importance of a pod's labels. And so here we go now. How do we associate pods with a replica set? And the way you do it is by means of this selector. So the way you interpret what's being said here is, if we take all of this, this replica set is going to associate itself with any pods that have the label app HTTPD. And again, this label is completely arbitrary. The key is arbitrary. The value is arbitrary. But I guess it has some meaning maybe in the context of your application. So any pod that has this label, app HTTPD, then that pod will kind of come under the control of the replica set that we're trying to create here. The pod might have other labels, but as long as it has this label, then it satisfies the criteria that we're stating. The remainder of the replica set manifest file then is the template part. And in the template part, that's essentially where you give the specification for the individual pods that make up this replica set. So if you like, if you take from here down, that is what I've highlighted there is the specification for a pod. And if you compare that to the full contents, if we go back to our pod manifest file, it's essentially the spec for a pod. Let's see, sorry. It's essentially all of this here. So I could literally copy what I've highlighted there and bring that over into my replica set manifest file and paste it in under the template part. So again, uh, we have the metadata for the pod. We're giving our pods these names, and we are associating these labels. And there's only one, but there could be more. And it's no surprise that the label that I have um, attached to my pod specification matches the labels in the selector up here. Yeah. Okay. And the rest of the template then should be predictable enough. Our details of our containers. So I've decided in this container we're going to be running the HTTP D Docker image. I'm giving the container this name, which is arbitrary, and the ports that I want to have available. And HTTPD, does that use? Yeah, that uses port 80 as well. Okay, so again, the selectors and the labels are how we kind of match up pods with replica sets. And you might ask, well, I mean, if we're defining all of this in one manifest file, isn't it fairly obvious that the template for the pod is obviously because the template is contained within the same manifest file as the replica set? Isn't that obvious enough that the pods that are created by virtue of this template, they are going to be associated with this replica set? But there may be cases where there are other pods that were created from other sources, and those other pods also have this label. Well, those other pods would also come under the control of this replica set. So that it's kind of an edge case, but that could arise. So again, even though I'm creating a replica set here, manifest file, I may already have other pods running in the cluster, and those other pods have the app HTTP label. Well, when I create this replica set, those other pods will actually come under the control of this replica set. As I say, it's kind of an edge case, but that's the rationale kind of behind it. Right, so if I now apply this manifest, so it's the same command, oc apply, and -f, and then the name of the manifest file, which in my case is 02, I think, isn't it? Now, just before I do that, yeah, I can tell you now that I don't have any pods running at the moment. And if I now go OC get pods, or PO for short, then I have two pods running. And that would match up with the fact that in my manifest file, I had the replica count set to 2. Now, okay, so I've got two pod resources, but what I also have is RS is the short for replica set. And when I do an OC get RS, I'm asking the cluster to show me all the replica set resources that I have created. And this is the replica set that was just created for me. The name of the replica set, I should have called it Nginx is a bad name actually because I'm creating HTTPD pods, but spare me that embarrassment. So that's the name of the replica set, which it got from here. That doesn't add up, is it? Hang on a second now. That doesn't add up. Am I looking at the right file? Oh, sorry. Sorry. Let's undo that. The name of the file is 02-2 HTTPD. Let's undo that. Let's delete it this way. Okay, let's try that all over again. So it's OC apply and OC2. OC get pods again. I've got 2 pods and I've got 1 replica set. Okay, so here's my replica set here. The name is that, which it got as from the metadata. The 2 here means that there are 2 pods currently linked to this replica set. Um, that was kind of the desired number of pods, and the number of pods that are actually running under this replica set is also 2. And both of those pods are ready to receive requests, if you like. That's how you interpret all of this data. And then when we looked at the state of our pods, we do indeed have 2 pods. And if you look at the names of the pod names are kind of derived from the replica set name. Like the replica set name was httpd.replica, and that's also the prefix of both of my pod names. And the remaining part of the pod name is just a hash value, randomly generated hash value to distinguish one from the other. And we know what this kind of stuff means. The 1/1 means there's only one container in the pod, and that one container is running, the both in running state, etc., etc. And if we do a OC, if we look at the wide, uh, see over here, one of the pods is running on worker node 2, the other pod is running on worker node 1. So, that's a really good example of this availability, uh, the availability kind of quality, if you like. If worker node 1 or 2 happen to go down, then my app is still available because it's running on the other worker node. And both of the pods have IP addresses that are private. Now, The advantage here, one of the advantages of replica sets is if one of these pods is deleted or crashes accidentally, then Kubernetes will automatically recreate the pod for us because my replica set says I always want to have two instances of the pods available. And so it kind of monitors that state for us. So to prove that, if I just delete one of the pods manually, let's just take this one. All right, this one here. And if I straight away go OC get pods, suddenly I've still got two pods up and running. But if we look at the details, so my two original pods were, let's see if we fit them all into one screen. These are my two original pods, so F1, etc., and 1B. Down here, I still have uh, 1B, and this is the new pod that it created when I deleted one of my pods. The new pod that I created, if we look at its IP address, it won't be the same as the pod that I deleted. Let's prove that. So the IP address of this pod here is 10.129.365. Whereas this one, which was the one that was created, was, oh, I didn't get its IP. Do I have its IP address? Yeah, that's its IP address there. So 10.129, 6364 versus 10.129, 365. So it's a different IP. It is back on the same worker node. So I deleted the pod that was on worker node 2 and it recreated it on worker node 2. Again, for availability reasons, it didn't create it on worker node 1, which wouldn't be a good idea. If it had put it on worker node 0, that would be fine as well from an availability point of view. So that's the kind of benefit of replica sets. Now, what I've illustrated there is what's termed self-healing. This is something that we often hear about in relation to Kubernetes. It's a self-healing platform, and this is one illustration of self-healing. In other words, when a pod crashes or is deleted, then the Kubernetes will automatically recreate it. It will heal the situation and get the state of the replica set back to its desired state, which in our case is having two running pods. So we have two types of resources here, replica sets and pods. And there's obviously a link between them. Okay, so we did that. And then we looked at the pods, and then we looked at the replica sets. That's all fine. I've also just illustrated the self-healing idea as well by just manually deleting a pod. The self-healing also works if a container within a pod crashes, then Kubernetes will automatically try to restart the container within the pod. It doesn't have to recreate the pod. Just has to try and restart the container within the pod. But it monitors the state of the containers within a pod as well. Now it's a little bit trickier to demonstrate that. I might do it actually in a subsequent lecture. Oh yeah, so that's really what I illustrated. And again, it's important to note that when a pod is deleted and Kubernetes automatically recreates that pod, provided it's part of a replica set, then that new pod's IP address is not going to be the same as the one that was deleted. This self-healing would not have worked yesterday. Yeah, yesterday I wrote a manifest file for a pod, and then I applied that manifest and it created that pod. Now, I think if I deleted that pod, then it won't recreate it because it's not part of a replica set. The third type of resource is a deployment. And a deployment is essentially kind of a wrapper for a replica set. So there's a very tight, close relationship between the notion of a deployment resource and a replica set. What deployments give you over and above replica sets is some extra uh, kind of benefits in that it supports rollout and rollback, and I'll illustrate that in a moment to you. You can also define a kind of deployment strategy, which is something you can't do with replica sets. And there are other benefits to these deployment resources, but they are very similar to replica sets in terms of the manifest file anyway, and we'll see that in a moment. Um, when you create a deployment resource, what happens behind the scenes is it creates a replica set associated with that deployment resource. And we know once we've got a replica set, then pods are created. So the kind of the hierarchy is a deployment manages a replica set. A replica set manages a set of pods, and a pod manages a set of containers that are running within the pod. Okay, so that's your hierarchy. Deployments on top, replica sets next, pods next, and at the very bottom, I guess, is containers, even though we don't have kind of manifest files for containers. So that's what I'm kind of talking about here. So let's look at a manifest file for a deployment resource. And I suppose, when you're starting off anyway, the first thing we tend to do is find out what's the API version for deployments and what's its short name and what's its kind. So again, if we use the OC API resource command, and this time we're looking for deployment. So it's this one here. So deploy is just a short name. The API version is actually the same as the API version for replica sets. And the kind is deployment. Okay, so armed with that knowledge, let's go away and write our manifest file. And again, I think I'm using Nginx here just for simplicity. So yeah, the API version is app/v1. The kind is deployment. The metadata is we're just using the name property, which again is arbitrary. Now I'll come back to the annotations in a moment, but the reason I'm including and the annotations, you can have custom annotations, but a lot of the annotations are kind of defined by the Kubernetes framework itself. So this is one predefined annotation. Annotations are just key value pairs, just like everything else really in a YAML file. But I'll come back to the annotations in a moment. Moving on then to the spec for a deployment. And if you look at all of this, right, and compare it to a replica set. So we begin with replica count, etc. And if we go back and look at our replica set, uh, like the spec here is almost the exact same. In fact, it is, you could do a copy and paste. So back to our deployment. So the spec for the deployment, number one, is how many instances of the pod do you want to have created? Again, I was stuck with two for no particular reason. Our selectors and labels play the same role as they did with a replica set. So what we would now say is that this deployment resource that we're defining here, we want it to be associated with any pods that have this label attached to them. And then the template part of the deployment is kind of the template for the pod, the template for the pods that will be linked to this deployment. Again, we need this for security, for permissions purposes. Sorry, beg your pardon. Sorry, that's just the metadata for our pod. And again, the labels part has to match up. The labels part needs to match up with the selector part that we have up here. Then we have the spec for our pod essentially. This is for permissions purposes, otherwise the pods won't be able to pull the image that they require, and the rest is familiar to us. So again, the template is essentially a definition of a pod. And if you want to refamiliarize yourself, well, what's the definition of a pod? If we go back to this one, it's the spec. Sorry, it's from the metadata part right down to the end is the template. Let me just leave those two open now for a second. I'm not confusing you. I'll leave that open and come down to our deployment. So the template is a template for a pod. Every pod has to have metadata. It has to have a specification. If we go back and look at the pod file, it has metadata and it has a specification. So, that does add up in our template. And the labels in the template, or the labels in the, sorry, no. Yeah, the labels in the template need to match up with the selector in the spec for the deployment. But the spec for the deployment is essentially the same as the spec for a replica set. And the rest of the template is just the details, configuration of the various containers or container within our pod. So it can get a little bit tricky. Like we've got this spec for a pod here. We've got the spec for a replica set, kind of essentially here, which is also the spec for a deployment. Yeah. And if we now try and apply this deployment manifest, I might have made some error now, some typo in the file, I'd say. Oh, I think what's actually happening now here is my my login token has expired, so it looks like I need to log in again. Okay, so you can see my screen again, and I've just logged in again. So I'll try to, let's see what the status of our account is. If I go OC get pods, right, I still have those two pods from the replica set. And if I now go and apply my deployment manifest, so I've got two pods from the replica set earlier on, and I've also now got two pods for the deployment. In terms of replica sets, here's the new replica set that was created by my deployment. And this is the replica set that I created directly, if you like. This one was created, the second one was created indirectly when I applied my deployment manifest. And if I look at what deployments have I deployed, then OC get deploy is the short name for deployment. I could have give the full name. Yep, I've got one deployment called Nginx depl, and Nginx depl was the name that I gave it up here. Okay, so this second replica set now, this new replica set, it has all of the benefits that I illustrated earlier on for the HTTP replica set. As in, if I delete one of the pods, it'll automatically be recreated and all of that. Now, one of the extra benefits of deployments is it can manage rollout and rollback for us. Now, that brings me back to the annotations that we have in the manifest file. Uh, so the annotation has this name, okay, which is just prescribed by Kubernetes itself. And if you could think really of this as it's a bit like a Git commit, where the commit message is this bit over here, except like where the messages is associated with a deployment of our deployment resource. Okay, so this is the kind of the commit message associated with the first deployment of this deployment resource. And if we go back to our slides, so we're told here that um, each deployment update, so if I make a change to the manifest file and I want to apply those changes, then what actually happens behind the scenes is that Kubernetes will create a completely new replica set for this updated deployment. It will hold on to the previous replica set, but it creates a new one and it honors the new updates, if you like. If I make another change to the deployment specification, to the manifest file, and I apply that, it's going to create a third replica set, and so on and so forth. So it keeps kind of a record of each deployment update. And one aspect of that record is it actually maintains the replica sets that apply to each update. So uh, let's do that. And the way you can find, well, how many deployments have I made already of a particular deployment resource? I'm not saying it on this slide. I think I'm saying it on this slide here. If we use the OC rollout history deployment and then the name of the deployment, we'll get a full list of all the deployment updates that have occurred for this deployment resource. So let's just look at that. OC rollout. And sorry, I don't want that. Let's try that again. Sorry, I'm missing history, am I? Deployment. OC rollout history. Sorry, is the word I'm missing there. Okay, so it's telling us there's actually only been one deployment or application of this deployment resource, and that's right, because I only ran the apply command once. And this kind of message here, or what it calls it the change cause, that matches my annotation. And okay, that's all it's telling us. That's fine. So let's actually do something. Let's change the version of the image that we want to use, and let's change it to let's say 1.25, and let's change our annotation as well. Now I've just got these in as comments here, just as a convenience, but that's not really the way you would do it. So if I comment out that and comment in that, so the message is saying change to Nginx version 1.25.0. And there could be other things that you can change in this spec here, like, you may want to change the port number or whatever, add a second container, etc., etc. So I've made a change, and if I now apply this again, Now, if let's see, what will I do next? Let's look at one of the pods actually. Let's take this one here. If I go OC describe and I want to look at pod, let's take this one. Another typo. And in particular, if I look at the containers, see here where the image that's being used is version 1.25, which is the new version that I updated it to. So that seems to have worked. So it actually deleted the old images and deleted the old pods and created new pods with the updated kind of container configuration, if you like. That's the first observation. The second observation is if we run that history command again, we can now see that there were two revisions to our deployment resource. Okay, and these are the messages telling us like what's changed between one and the other. Uh, if we look at what replica sets do we have in our account, we actually have three. Now, okay, this was the one that we created at the beginning of the lecture. We're not interested in that. But if we look at the next two, um, what I should have told you as well is that the names given to these replica sets are derived from the pod names. Sorry, are derived from the deployment name. So my deployment, sorry, now I'm going off on a little bit of a tangent here. So just let me clear off this. If I go OC, get deploy or deployment, that's the name of my deployment, which it got from the metadata. And the replica sets, their names are kind of derived from that. Okay, so if I bring up my replica sets again, they both begin with Nginx deploy and then a hash value. But I have two replica sets. But if we look at the details of the replica sets, the second one here, it doesn't have any pods. That's what we're being told from all the zeros here. There are no pods currently running as part of this replica set. And that would make sense because really the current replica set is this one. This is the one that applies to the update that I made to the deployment. And it has two pods running and they're all ready, etc., etc. If I make another change to my deployment, so let's change it to, we'll stick with just changing the image version number, but it doesn't have to be that. So I think version 29 is another version that exists. I'll change my message, if you like, to this one. Okay, change to Nginx version 1.29. Let's apply that. I can't really tell now, but if I do a describe on any one of these pods, Hopefully they will be running version 1.29. Let's see, where is the... Yeah, there it's running Nginx version 1.29. So the new pods have been created with the correct configuration. If I look at my replica sets, I now have three replica sets, both with the Nginx depot name. Or do I? Yeah, I do, yeah. And it looks like, this is the current replica set. The other one, this one, and this one relate to previous revisions. If I look at my history, I have three revisions. Now, okay, so that's great. It's keeping a kind of a record of the various updates that I've done to my deployment. But what if I want to roll back? What if using version 1.29 of the Nginx is causing problems in my application and I want to roll back to the previous update, which would have been 1.25? Rather than me having to, do that kind of manually um, shut down pods, etc., or maybe go back and start editing my deployment and change it back to version 1.25 and all of that. I can get Kubernetes to roll it back for me. So in my slides, I talk about deployment rollback. And so the command to do that is this command here. So it's rollout, undo, uh, deployment. So it looks like rollout is something that you can apply to different types of resources, not just deployments, but in our case, it's a deployment, and then the name of the deployment. And you're telling it here which which revision of the deployment do you want to go back to? Okay, so you can pick any one of them here. So let's say we have three deployments, and let's say I want to go back to revision number 2, which is running Nginx version 1.25. So if we type in that command and hit return, okay, so it really does it very quickly. So let's now check one of these pods. Hopefully they're running version 1.25. And yep, it's running version 1.25. And if I look at my history now, uh, like revision 4 was is the fourth revision, but it was as a result of a rollback. And we can see from the message anyway, change in deployment to 1.25. That's kind of the most recent revision that we've done of our deployment. So it's kind of shuffled the deployments for us, if you like. So that's so this rollout and rollback is just one of the benefits that you get from deployments as opposed to replica sets. But a lot of what deployments uh, is comprised of is really being managed by replica sets. Okay, I'm not going to go any further than that today. Um, I will have a lab for you next week where essentially you go through all of the stuff that I've been doing here in the lecture so that you can practice all of these things yourselves and get comfortable with the fundamentals of Kubernetes. I'll pause just for any questions that you might have on what I've demonstrated so far this morning. No questions? Okay, I'm going to stop lecturing and um, I'm going to let you use the remaining time to go back to the assignment and start working on it. I haven't received any questions from people so far on the assignment over Slack anyway. So I'll let you work away and I'll stay online up until around 12 o'clock, just in case you do have any questions about either what I've just been demonstrating or in relation to the assignment. All right, I'll shut down the meeting at this stage. Talk to you later.